machine and robot twin that can, based on our edge computing, connecting our machine and robot immediately.
Accomplished many exciting things and have been partnered with me all along the way. Today we're going to talk about where we are in the industry, where we're going to go, announce some new products, exciting new products and surprising products. Like the internet, just like electricity, needs factories. And these factories are essentially what we build today. They're not data centers of the past. A $1 trillion industry providing information and storage, supporting all of our ERP systems and our employees. That's a data center of the past. This is similar in the sense that it came from the same industry. It came from all of us, but it's going to emerge as something completely different. This is not a video, this is computer graphics. It's generated by GeForce. This is a brand new GeForce 5060, RTX 5060. And this is from ASUS. My good friend Johnny is in the front row. And this is from MSI. And we took this incredible GPU and we shrunk it in here. Does that make any sense? This is incredible. And so this is MSI's new laptop with 5060 in it. GeForce brought CUDA to the world. Right now what you're seeing is every single pixel is ray traced. How is that possible that we're able to simulate photon and deliver this kind of frame rate at this resolution? Well, the reason for that is artificial intelligence. Computer architectures and computer systems, CU equivariance and CU tensor, contraction of tensor mathematics, Megatron. This whole row, this whole column here consists of all of our deep learning and all of our libraries necessary for training as well as inference for deep learning. This revolutionized computing. And it all started with all these libraries. Not just CUDA, but cuDNN. On top of cuDNN, there was Megatron. Megatron, then TensorRT-LLM, and then now lately, this brand new operating system for large AI factories, Dynamo. Blackwell does. Grace Blackwell broke just about everything. And all of you in the audience, many of you are partnering with us to build Grace Blackwell systems. I'm so happy to say that we're in full production, but we can also say it was incredibly challenging. Although the Blackwell system based on HGX has been in full production since the end of last year, and has been available since February, we are now just putting online all the Grace Blackwell systems. They're coming online all over the place every single day. It's available in CoreWeave now for several weeks. It's already being used by many CSPs, and now you're starting to see it coming up from everywhere. Everybody starts to tweet out that Grace Blackwell is in full production. What the last generation looks like, the B200, this is what B300 looks like. Notice right here in the center, it's 100% liquid cooled now, but otherwise, externally, it's the same. You can plug it into the same systems and same chassis. And so this is the Grace Blackwell GB300 system. It's 1.5 times more inference performance. The training performance is about the same, but the inference performance is 1.5 times more. Now this particular system here is 40 petaflops, which is approximately the performance of the Sierra supercomputer in 2018. Create what is called NVLink. This is the world's fastest switch. This NVLink here, right here, is 7.2 terabytes per second. 9 of these go into that rack. And those 9 switches are connected by this miracle. This is quite heavy. That's because I'm quite strong. I made it look so light, but this is 70 pounds. And so this is the NVLink spine. 2 miles of cables, 5,000 cables structured, all coaxed, impedance matched, and it connects all 72 GPUs to all of the other 72 GPUs across this network. This 1 gigawatt factory is probably going to be about 60 to 80 billion dollars. Out of that 60 to 80 billion dollars, the electronics, the computing part of it, these systems are 40, 50 billion dollars of it. So these are gigantic factory investments. The reason why people build factories is because you know the answer. The more you buy, say it with me. The more you buy, the more you make. That's what factories do.
Blackwell is an engineering marvel. It begins as a blank silicon wafer at TSMC. Hundreds of chip processing and ultraviolet lithography steps build up each of the 200 billion transistors, layer by layer on a 12-inch wafer. The wafer is scribed into individual Blackwell die, tested and sorted, separating the good dies to move forward. The chip on wafer on substrate process, done at TSMC, SPIL, and Amkor, attaches 32 Blackwell dies and 128 HBM stacks on a custom silicon interposer wafer. Metal interconnect traces are etched directly into it, connecting Blackwell GPUs and HBM stacks into each system and package unit, locking everything into place. Then the assembly is baked, molded, and cured, creating the Blackwell B200 superchip. At KYEC, each Blackwell is stress tested in ovens at 125 degrees Celsius and pushed to its limits for several hours. Back at Foxconn, robots work around the clock to pick and place over 10,000 components onto the Grace Blackwell PCB. Meanwhile, additional components are being prepared at factories across the globe. Custom liquid cooling copper blocks from Cooler Master, AVC, Auras, and Delta keep the chips at optimal temperatures. At another Foxconn facility, Connect X7 SuperNICs are built to enable scale-out communications, and Bluefield 3 DPUs to offload and accelerate networking, storage, and security tasks. All these parts converge to be carefully integrated into GB200 compute trays. NVLink is the breakthrough high-speed link that Nvidia invented to connect multiple GPUs and scale up into a massive virtual GPU. The NVLink switch tray is constructed with NVLink switch chips, providing 14.4 terabytes per second of all-to-all bandwidth. NVLink spines form a custom blind-mated backplane, integrating 5,000 copper cables to deliver 130 terabytes per second of all-to-all bandwidth. This connects all 72 Blackwells, or 144 GPU dies, into one giant GPU. From around the world, parts arrive. From Foxconn, Wistron, Quanta, Dell, Asus, Gigabyte, HPE, Supermicro, and other partners to be assembled by skilled technicians into a rack-scale AI supercomputer. In total, 1.2 million components, 2 miles of copper cable, 130 trillion transistors, weighing 1,800 kilograms. From the first transistor etched into a wafer to the last bolt fastening the Blackwell rack, Every step carries the weight of our partners' dedication, precision, and craft. Blackwell is more than a technological wonder. It's a testament to the marvel of the Taiwan technology ecosystem.
The Taiwanese government, Nvidia, TSMC, we're going to build the first giant AI supercomputer here for the AI infrastructure and the AI ecosystem of Taiwan. Thank you. Is there anybody who needs an AI computer? Our goal is to take these Blackwell chips that are, you could see how big they are, and turn it into one massive chip. Now, the ability to do that, of course, was made possible by NVLink. But it understates the complexity of the system architecture, the rich software ecosystem that connects it all together, the entire ecosystem of 150 companies that came together to build this. This architecture and the entire ecosystem in technology and software and industry has been the work of 3 years. Nvidia Constellation. Nvidia Constellation. Well, as you know, we have been growing. And all of our partnerships with you have been growing. The number of engineers we have here in Taiwan have been growing. And so we are growing beyond the limits of our current office. And so I'm going to build them a brand new NVIDIA Taiwan office. And it's called NVIDIA Constellation. Woo. We've also been selecting the sites. We've been selecting the sites, and all of the mayors and all the different cities have been very kind to us. I think we got some nice deals. I'm not sure. Seems quite expensive. But prime real estate is prime real estate. And so today, I'm very pleased to announce that NVIDIA Constellation will be at Beitou Shili. We have negotiated the transfer of the lease from the current owners of that lease. However, I understand that in order for the mayor to approve that lease, he wanted to know whether the people of Taipei approve of us building a large, beautiful NVIDIA Constellation here. Do you?
Yes.
He also asked for you to call him And so I'm sure you know his numbers. Everybody call him right away. Tell him that you think it's a great idea. So this is going to be Nvidia Constellation. We're going to build it. We're going to start building as soon as we can. We need the office space. Nvidia Constellation, Beito, Shilin. Very exciting. Okay.
Cool.